angle of elevation. Yeah. So basically you have to always think where the observer is. So this is the this. So if you're looking at the top, that's the angle of elevation. An angle of depression is when the observer is on top and looking down. So you draw this dotted line, you draw the horizontal, and this is your angle of depression. So here the observer is on top. He's looking down. Both the angles are angled with respect to the horizontal and the line of sight. We call it line of sight. So you have to think which is the line of sight. Is the angle between the horizontal and the line of sight. So angle of elevation. Compass bearing and true bearing. What is compass bearing? South, east, west. We also have southeast, southwest, northeast, northwest. You also have south, southeast. It's between southeast and south. South, southeast, south, southwest, north, northeast, northeast, east. Yeah, but we don't use it just. What is true bearing? So see, so if you have point A and B, to find the bearing of B from A, this bearing is, let's say, 54 degrees. So you take the angle with respect to north, always with respect to north in clockwise. 2 points you need to remember. You need to take the angle with the north, and you need to take the angle with the clockwise direction. So that's called true bearing. Okay. So if you have a point, let's say, if you have a point P and Q, so north, what is the bearing of Q from P? You look at this angle. So this angle would be how much? Let's say 150, 154 degrees. I'm just taking any random value. It may not be. Okay. You can also have over here bearing of D from C. Bearing of D from C. This angle. So what does that mean? Let's say 200 degree 200 degrees. Yeah, 180 and more. Yeah. So these are known as bearings. It can also come this way. Bearing of S from R. So it will be this angle all the way. So let's say 314 degrees. So bearing, this is called true bearing. True means you're taking with respect to north. True bearing is you're taking with respect to north. Three-dimensional problem solving. Yeah, you have to obviously look at a diagram and you have to solve. I mean, there's nothing I can. We'll have to do the sums actually. First the aeroplane is here, overhead. Correct? There's a person standing over here. Huh? And then 2 minutes later, so 2 minutes later the plane will go ahead. The 2 minutes later the plane goes ahead. Correct? And the angle of elevation of that plane, this angle of elevation of that plane is 25 degrees. Correct? 2 minutes later. So what you can do in this case is, yeah, 2 minutes later, so distance is speed into time. So speed is 350 meter per second into time is 2 into 60. Correct? So that's, where's my calculator? One second. Yeah. So 42,000 meters is the distance traveled by the aeroplane. So obviously from here to here it's 42,000 meters. So that means obviously this will also be 42,000 meters now if you take it horizontally down. You want to find out the altitude of the aeroplane in kilometers. So 42,000 meters, if you convert to kilometers, that will be 42 kilometers. Because to convert 1,000 meter makes 1 kilometer. So then what will you do? So you can use your tan 25 degrees is equal to h upon 42. So h is equal to 42 into tan 25. So 19.6 kilometers is the height of the plane. Yeah, in the end also you can divide by 1000, no problem. Diagram is going to be difficult slightly in this case. So ship A leaves a port, correct, and sails due east. So east is this way, 28 kilometers. So let's say, so the port is P, A, due east is 28 kilometers. Ship B leaves the same port and sails 49 kilometers, we don't know which side. Yeah, so you draw 49 kilometers randomly over, let's say here. Correct? Yeah, so this ship B and sails 49 kilometers. The two ships are 36 kilometers apart. So the distance between the two ships, so this distance is 36 kilometers. What is the bearing? So you draw the north. You draw the north. What is the bearing that this is sailing? That's up to you now. Right. In this case, you have to find a bearing. So if you want to find a bearing from this, so obviously you'll use your cosine rule and get this angle first. So you can say your cos theta is equal to 49 square plus 28 square, correct? This square plus this square minus the opposite side square upon 2 into 49 into 28, correct? So if you do cos inverse of that on your calculator, so if you do tan cos inverse of that, your answer will come as 46.5 degrees, correct? So therefore your bearing would be how much? 90 minus that. Bearing is respect to north. So 43.5 degrees. So 043.5 degrees true is the bearing. Now you can also choose the sum in a different manner. You can also, the diagram you can draw in this manner also. You have your ship A which is going, let's say 28 kilometers. Now, this can go like this also. Correct? 36 kilometers. B, you join this. This would be your bearing then. Your bearing would here be how much? 90 plus 46.5. Okay. These are the two possibilities which are there. No, not necessary. You can do any one. Any one because they haven't specified. You consider respect to north. See, John and Ellen have job interviews in different cities. John leaves the airport traveling 180 miles along, heading 25 degrees. So this is the airport. Let's call airport as A. Now John is heading 25 degrees. So this angle with the north is 25 degrees. Correct? And this is where John, and this is 180 miles. 180 miles. Ellen leaves the airport and travels 580 miles along 295. So this is your 180, 270, correct? 295 is all the way somewhere here. And there's 295. So when you're drawing a diagram, also make it a point that you keep the proportion. So this 580 miles, which has to be longer than 180, and this bearing is 295 degrees. And this is where Ellen is. If Ellen decides to catch a flight to John that can travel 500 miles per hour, how long will it take her to reach the destination? So Ellen wants to travel this. How long? Is it 90? Correct. So 25. So what will you do? Sum of, so if you do this, so 360 minus 295. How much is that? 65. 65. So this angle would be 65. So therefore angle A will become what? 65 plus 25. That's how much? So it becomes 90. And now can you use Pythagoras theorem and find out EJ? Right? And then you do speed is equal to distance over time. So 580 square plus 180 square. Right? So that's 607.2898. Don't round off in middle. Miles. Now you have to find out time. Time is equal to distance over speed. So 607.289 divided by 500. Divided by 500. That's how much? 1.21 hours. So see, once again, if you're drawing it, I'll tell you what to do. What you do is, if you're drawing this, you draw a square. Draw a square. Draw a square behind it. Draw a square behind it. Okay? And then you join that. Correct? So the cube has length of side 12. The angle between DF and BF. So I'm assuming A, B, C, D. I don't know which is F. So A, B, C, D, E. Let's say F. So DF. No, they'll give you the diagram generally. So DF and BF. DF and BF. This is the angle that you have to find. It's not 90. This will be in some acute angle. No? So yeah, because all the three are equal. No? So suppose, so yeah, it's right. So what do you have is, suppose if I draw this face, yeah, correct. So see, look here. This is there. Now this is 12. This is 12. So BF will be root of 12 square plus 12 square. So that will be basically 2 root 12. Correct? The diagonal of a square is L root 2. So length multiplied by root 2. So 12 root 2 I mean. Yeah. So this will be 12 root 2. Achha. DF is also diagonal of that. So that will be 12 root 2. Correct? And if you do dot DB, that will also be 12 root 2 because it's a diagonal of this bottom square. So all three sides are equal. Therefore, angle DFB will be how many degrees? 60 degrees.